Please welcome Paul.
Thanks very much. I'm sorry I'm dressed like an accountant. My only excuse was I came from a meeting with my auditors today at the Institute, so I always felt like it's good to put a tie on when you're meeting with your auditors. So thanks for the invitation. I sort of, it's quite an eclectic mix of things that I thought I would put together, because given the nature of what 80,000 hours is about, I thought I would try and put something together about what working in not-for-profit organisations is all about, and the sort of challenges and skills mix of working in those organisations, but also a little bit about the work I've done over my career in public policy, particularly around some of the stuff in climate and civil contingencies. And then I might try, if I can at the end, to bring that together and say a few words about what I think is effective in public policy making, although that's a bit of a challenge, I think, but I'll do my best. But please chip in as I go through if you've got any questions or comments, or you want to talk about any bits that I've got to in the talk. I thought I would just ask quickly, though, if I can, the kind of mix of what you are and where you come from. So are you generally scientists? Are you people interested in policy? Okay, and are you interested in doing things in organisations that you might one way or the other define as ethical? Is that okay? So that's interested in ethical policy with a science bent. Okay, well, hopefully it will match well with your interests. So I thought I'd start by just maybe discussing three things principally. What do we actually mean by not-for-profit organisations? And maybe I can challenge you a bit on that. What does a typical kind of skills profile look for people who work in not-for-profit organisations? And this is quite a tough one to do in a few minutes, but what do I think the strengths and weaknesses of a lot of not-for-profit organisations are? But perhaps I could start by asking you what you think is the answer to those questions. So on any of the three, if anyone's bold enough to have a go, I mean, what do you think a not-for-profit is? What do you think people who work in not-for-profits look like? They obviously wear ties, but dodgy ties. But I mean, what do you think a not-for-profit is?
Answering the second question,
yeah.
An ability to be very flexible, like with skills, in terms of, you can't have a set thing that you've got to do. Be flexible with different disciplines.
Yeah, so something about flexibility. I think that's a fair reflection on what we've seen in practice. Anyone else brave enough? In particular, the bit of not-for-profits that I've worked a lot in, professional learner societies, my perception of them before I ever went in them was a bunch of grey-haired men surrounded by burnt-down candles and cobwebs, and so I've got a bit of a backwater, really. I guess the first thing I would say is about this definition of not-for-profit. Not-for-profit doesn't mean the organisation's not commercial in the things that it does, because the organisations have to get their money from somewhere. And so if I look at the Institute of Physics, we turn over £65 million a year. It's a group of 8 companies. The charity is the holding company, but we have 7 commercial trading companies that sit underneath, generating the income to do the charitable things that we do. So it's very commercial in the way it operates as an organisation. We have lots of people who know how to manage income and revenue and do salesy kind of things. So I have a global publishing business. So I think not-for-profit doesn't mean not commercial. It just means the things that you do with your profit, you put back into charitable aims. So you don't end up paying a small number of shareholders large amounts of profit dividend. You actually put the money to good use. But it doesn't mean you don't try and earn a profit. It's just how you spend that profit. And so that often changes the way people think about who works in not-for-profit organisations, because a lot of people think about these as the typical NGOs, things that you might give money to on the street, campaigning organisations. But the not-for-profit sector is quite broad. Of course, it does involve those campaigning organisations. And actually, when you look behind those campaigning organisations, you find that actually they're quite commercial as well. So if you spend time unpicking Oxfam or Friends of the Earth, you find that there's a there's a strong corporate commercial ethos sitting in the middle of it, driving the way they deliver their charitable programs. So the skills mix looks quite interesting in these organisations. It's quite a diverse community. You get very small kind of not-for-profits that are often built up around campaign issues. But some of the not-for-profit communities in the UK are quite big as organisations. The Institute, as said, turns over 65 million. We have 600 employees working for us in something like 8 countries. So we're quite big organisationally, some of the not-for-profit sector. And there comes with that quite complicated governance structures. So the people who work in these organisations have to know how to run a business. They have to know how to manage budgets. They have to know how to run projects. You have to know how to build relationships with other organisations. And most not-for-profits end up delivering the things that they do with a wide range of delivery partners. So you have to be very good at working with other organisations in delivering the things that you want to do. So it's probably not the mix of people you kind of expect when you first think about not-for-profits. What are their strengths and weaknesses as organisations? Well, one of the challenges I've found of working in not-for-profits probably for 10 years now of a range of sizes is, and the strengths and weaknesses, things are often both a strength and a weakness you find. And what I've found is it tends to attract like people. And that's never a good way of building a team in an organisation. You want a mix of people with different skills, different backgrounds, different perspectives on the world. But actually one of the challenges is that it tends to attract people of a similar view and a similar skill set. On the one hand, that's great because you can align quite well behind the things you want to do. But actually it's a bit of a challenge because then you have to retrain people and develop them. And it makes for a very challenging sort of development programme. So I think that's a real issue. I think one of the challenges for not-for-profits, unlike many commercial businesses, is these days they're both service businesses, so they're delivering a kind of community service, but they also deliver products as well. So most organisations are not structured in quite that way. Most organisations are either a product-related business, they build stuff, or they're a services-related business, they deliver a kind of service to the community. But a lot of not-for-profits try to do both. And that actually makes for quite complicated business models and the way you have to run the businesses. They have quite bureaucratic governance structures often, because the oddity about the UK is if you work in a company and you have a board of directors, those directors have to be registered with Companies House under the Companies Act. And the board is held accountable for the decisions of that company. And you could be struck off or treated accordingly or kind of removed and whatever. In UK charities, the Charity Act doesn't do the same thing. So you tend to find that the people who are held accountable in charities are the trustees. So that one warning to you, if you ever decide to volunteer as a trustee of charity, be careful about what you're getting into and the liabilities that comes with that. It's the trustees who are held accountable, but the people who work in the charity aren't, unlike in a commercial company. So what you tend to find is that the trustees don't have much day-to-day involvement, but they carry a lot of the responsibility for the decisions that those who work on a day-to-day make. So you tend to find that in order to give the trustees some comfort, you have a lot of detailed governance meetings where the trustees can feel comfortable that the things that are going on are as they should be. So in one sense that's very good because these bodies are quite well regulated and you have a lot of engagement with your kind of trustees. But on the other hand, it can make them a bit cumbersome from a governance perspective. So they are interested in challenging organisations, I think, and I hope to convince you that by the time I get to the end that they do interesting things and they're worthwhile thinking about working in. And probably whatever you're doing and whatever skill set you have, you've got a lot to contribute to the not-for-profit sector, I'm sure. So I'm going to talk about a smaller charity that I'm involved in, but I will focus a lot more on learner societies and professional bodies because that's where I'm sitting at the moment. And I think they do a kind of an interesting mix, so I want to kind of sell that to you through a few examples. How many of you here belong to a learner society? professional body. And practically every learner society, I would say, that will cover all of whatever you're studying will have free membership for students, probably without exception, or if they charge, it'd be about a tenner or something. So I'm kind of interested that only a few of you are a member of your professional bodies. Do you engage, those of you members, do you engage with them much? That's kind of interesting. Those of you who are not a member of, do you know you've got a professional body or a learner society looking after your discipline? No? Is it so? How come you've not engaged with them or you've not become a member? Just don't know about them? Okay, so that's kind of interesting, isn't it? Because you're probably at that point where you're beginning to think about careers, things to do, and these are organisations who have a look across the entire area of probably the careers that you're going to be working in. So one of the things I like about learner societies and why I've spent a lot of time working with them, both as a trustee and then working in the organisations, is they've got a really unique place in society. They look across the whole of the disciplines, and the only place that do that, right from when the little ones come in the door at primary school, through secondary school, further higher education, into policy and into commercial businesses. And these organisations often span the whole of that portfolio and doing interesting things in all that space. And so I would recommend go find your professional society, your learner society, and join it and get the services that come from them, particularly around careers and the connections with business and the opportunities it gives you to go and get involved with some of the committees and activities that they do. Because I can guarantee that whoever employer you go to will look quite favourably on that kind of thing. So that's my typical Wikipedia definition. If in doubt, go to Wikipedia. But that's they exist all over the world, but I would say my experience is they're held in particular high regard in the UK much more than in many other countries. And I think that's probably because a lot of them have been around a lot more. A lot of the learner societies in the UK were formed in the 1800s. There's a lot of longevity in there. They're a strongly trusted voice. A lot of them regulate the discipline. So the Institute of Physics accredits physics courses in UK universities. So you cannot run a UK university physics course that's not accredited because no students would join it. The departments, the universities wouldn't run them. So they play an important role in accreditation, both of studies in schools, in universities, but also in businesses, in regulation. So they have an important role in the community that way as well. So they are a very trusted voice with government as well, which is I'll come back to. So I thought I'd just talk a little bit about, I said in my title, I'd talk a little bit about education, a little bit about the public, and then a little bit about government and government policy. So this is something that we were just discussing with some trustees a few weeks ago. And it's about A-levels in science. So I don't know if you've ever looked at any pictures that look like this. So this is mathematics, this is biology, they're a bit faint, this is chemistry, and this is physics. And these are numbers of students taking A-level. So I'll ask the physicists amongst you, like processing data, what do you make of that graph? You can see the point here at which physics stopped being an entry requirement for medicine, okay, which it used to be. And interestingly, this is where we launched our schools education program to try and kind of rescue the situation, because we got to 2006 and we started to get really worried that this curve was going to disappear off the bottom of the graph. So you look at the change in numbers of people taking A-level physics, and there's some fascinating statistics around A-level physics. So some slightly horrifying statistic about A-level physics. So, and I apologise for concentrating on physics, but it's a good case study. So this is total cohort of students choosing A-level. If I was to say to you that 49% of co-ed state schools don't send any girls on to do physics at A-level, is a national scandal. I'll say that again. 49% of schools don't send any girls on to do A-level physics. And when you think about physics being of all the science disciplines, and of pretty much all of the disciplines, it's the one where if you track the employment statistics, it's the one that's going to lead you to the best paid career job. I mean, money's not everything, but people choose for a variety of reasons, one of which is career earnings. You're most likely to be employed. You can be employed in the most range of disciplines if you do a study in physics. And yet 49% of schools don't send any girls on to... it's very white, middle-class discipline. It's 1,000 schools, there's about 3,500 secondary schools in the UK. 1,000 schools only send 2 people or less on to do A-level physics. 500 schools don't send anyone on to do A-level physics. So there's a real problem in opportunity of access for people to enjoy the benefits of studying not just physics, but there's some similar challenges for the other science disciplines. And that goes right to the heart of challenges at school. One of the problems that physics has is because it's perceived as a very tough discipline. There's no evidence to suggest that physics is any more difficult to the other sciences or maths. But interestingly, and I should have brought the plot, if you look at the distribution of A-level grades, if you pick any discipline, you get a nice normal distribution of grades from A to C or E. If you look at physics, all the grades are A star, A, B. There's hardly any below that. And that's because schools are cutting off people before they go into E-level by telling them that physics is too hard for them and they're not clever enough. So if you pick another discipline, you get a nice distribution of grades. You don't get them in physics. Physicists are being cut out right at the beginning of GCSEs. So we decided we had to do something about this as the Institute of Physics, and we had a very large policy intervention in 2006, and since then we've been able to change the participation in physics at A-level by about 1/3, which is huge actually, with what's a big commitment, but in the grand scheme of things, a relatively small policy intervention. In a range of areas, it's to do with talking to schools about the way they timetable disciplines. It's to do with persuading schools not to put people off. It's to do with giving more equality of opportunity to girls. It's also to do with getting more physicists teaching physics. But it's an interesting example of how relatively small policy interventions can make a real difference. This is a plot of physics teachers. So this is initial teacher training courses just in England, and it's about the number of teachers going into teaching physics in the classroom. So this is the point at where we introduced a new scheme to encourage a scholarship scheme to encourage people with a physics degree to go and teach physics. We reckon just to get one specialist physics teacher in every school in the UK, we needed to recruit 1,000 a year, because the turnover of physics teachers is such that you need about 1,000 a year to have one through the training programme and into the teaching programme and to be maintained. So you can see we're falling well short of that, and that's probably why a lot of schools weren't teaching A-level physics, because they didn't have the physicists to teach it. So this was our scholarships, the impact of our scholarships programme. Interesting, this is the point at which government introduced Schools Direct, which was people going straight into schools rather than going to a PGCE training centre. And I think it's another interesting example of how policy interventions can have real tangible impact, both good and bad, in things that matter quite a lot in terms of our kind of education system. And learner societies are very, very heavily involved in education policy. So as well as thinking about recruiting and retaining teachers, about what's going on for girls in the classroom, we're also talking about setting curriculum standards for the UK. And that's true of all the other discipline societies as well. They're trying to help and shape the curriculums that are taught in schools, the way it's taught, and who's being taught. So it's a really important bit of work that the learner societies get involved in. Okay, that's a bit on education and challenges there. Let me talk about kind of communicating to the public. And I kind of like this. It just makes me smile when I show this bit. It's a little bit old now, but it makes me laugh when I look at it still, but I'm easily pleased. So this is about how, I don't really like the term, but how science literate populations are in particular countries. So I've very diplomatically hidden the UK in the middle. So, but the sort of Scandinavian countries come out as more scientifically literate, and the sort of southern European countries less scientifically literate. So if I show you the other half of the survey, so this is countries who, yeah, okay, so some of you are quite quick readers, okay, so this is what the population think about how good science is at solving the big challenges that they have. And it's upside down, so, you know, so in other words, the more scientific literate are, the less confidence you have in thinking that science can sort your challenges out as a society. It does make me laugh, but it's kind of disheartening as a scientist, I find, that, you know, kind of, it's a pretty poor job appraisal, isn't it? That we're kind of, that we're teaching people to understand scientific method, and yet, actually, the more we do that, the less people believe that science is useful. And I can't believe that can be right. Well, all history shows it's not. So I think we're doing something wrong, and I think there's a real challenge for us to have more people from the science community who can go and communicate to the public. So more communicators, so more of you are doing science, and I think it's important that it's people who are doing science and not just people like me who used to do science, but people who are actually doing science, getting out there and talking to the public about it. In my day, that was very much discouraged. It wasn't looked on very good thing to do, being a sort of media tart, you know, going out there selling your stuff to the cameras instead of getting on with your research. But it's so important that if you think about any areas of science that you might know about, pretty much all of them are playing an important role in big social challenges. And we'll come back to that a little bit later. And it's important to talk about that to the public because most science is publicly funded, for a start, I guess. I mentioned the education system, and one of the challenges we've got about education system is keeping people in the sciences for longer. So even if they don't want to be a scientist, they can understand a bit more about scientific method, scientific process, so they can make informed choices themselves when they have to face some of these challenges in adult life. And increasingly what we find is by encouraging youngsters to think about science as a career is important, because we're probably about 40,000 people short in terms of the STEM skills, the science, technology and engineering skills we need for what we think we're going to need in 2020. 40,000 short. So, you know, it's the place where we're going to have growth in jobs. And yet we're not getting people moving into science in the right numbers. And probably the reason for that is we don't have much science capital at home in different parts of those underrepresented communities. So that's parents, grandparents, got no background in science, no experience of science, no real interest in science. So when the children come home and talk about the interesting things they've been doing in science at school, there's no support at home that's telling them, well, they should follow that interest and because that's a good career for them. So building science capital at home is also quite important. And let me show you some of the challenges of communicating science to the public with just a nice neutral project, nothing controversial, I don't think anyway, that we did with the Met Office when I was at the Met Office. So we decided we then had the capability to do probabilistic weather forecasting. So we could start to issue probabilities in our weather forecast. Across a range of things, but particularly rainfall was kind of interesting. So we thought we'd better do a survey with the public to see how we should do this. So we developed these 4 different ways of representing probabilities. And we asked the public to vote. So we did a survey of 1,000 members of the public. So not massive, but big enough to get a good feel for it. And we had these kind of different ways of classifying probabilities. So I'm going to ask you to vote in a minute, so I'll just kind of give you a bit of forewarning. So this one was by words, so the idea being that the bolder and larger the text, the more likely it was to occur, and the fainter and smaller, the less likely. Well, you can see we didn't push the real boundaries of imagination much. This one is a little bit faint, it hasn't come out so well, but it's sort of the same idea as the text, but in pictures. So if the picture's bolder and bigger, it's more likely. If it's fainter and smaller, it's less. Well, we're a bunch of scientists, so we had to have error bars in there. So this is kind of averages and error bars, the chances it might be kind of warmer or colder or wetter or drier. And then percentages. Just straightforward, you know, kind of 80% chance of rain. And we asked them to sort of pick their favourite one. So I asked you to vote to see how you compare against our sample of 1,000. So if you like this one, put your hand up. It's nice to get a bit in each quadrant. Somebody voting for one of them. Okay, not a favoured one. What about this one? Thank you for being the champions of the picture one. What about this one? All right, yeah, favoured amongst the scientific audiences. About a third, I would say. And this one? Okay, that's pretty popular. About half, I would say. All of you who voted for this one, I'm going to ask you what 50% chance of rain means later. But do you want to guess what the public vote was? So almost exactly, not quite, but within 1% or so, almost exactly a quarter in each one. Which really, I mean, we thought it was going to go here and here. Actually, we thought that the public would stay well away from here, but it was almost. And you know the lesson we learned from that, and we did a few other things as well, and I've repeated this with other bits of scientific evidence in other bits of things that I've done over the years, and I've just come to the conclusion that actually the problem is that. There isn't one way of doing these things, but because people come at this, or their understanding of information comes from a very different place. And actually the social scientists have put some thinking around this, which they call framing. And I'll return to it a little bit in the discussion about climate in a minute. So people come to it from different frames of reference. And so how you express and communicate information, and this is quite important in the policy area, I think, depends very much on the frame of reference that you come from. And so having people who can deliver information in different ways and communicate information in different ways is quite important, which is why it's no good just to have one Brian Cox, by the way. You need a different mix of people working in this kind of public space talking about this stuff. I thought I'd show you this because this was my first experience ever when I went to COBRA, which is the government emergency, the committee that they call in the case of emergency. Prime Minister usually chairs it, although I think, if I remember rightly, Deputy Prime Minister chaired this one. And it was about Chernobyl, and looking at the age demographic of the population here, you don't remember Chernobyl, I suspect, but you've probably heard of it. So it was the nuclear accident at the Russian reactor that sent a radiation cloud over Europe. So it was one of the first times, I think, because afterwards the civil servants said to me they didn't ever remember an occasion where a scientist had presented some science data to COBRA, as usually what you just got was a piece of paper briefing you about what the kind of terrible things were about to befall the country on. And we thought afterwards that it was it was an interesting case study in itself, but it's quite a powerful image for the politicians, I think. So I'll see if I can play it, if the technology doesn't desert me. So if it works, this is the release of radiative material, and it's combined with the weather information. So you'll see how the radiation spreads over time. So it kind of went quiet in COBRA when we played this. So this bit they kind of liked because it was all going over France. And then you see the kind of weather systems bring it back round over the UK. Off the back of that, we introduced a programme, or government introduced a programme, about farmland management in most of the concentration areas. There's still bits of Wales that they don't farm with sheep farming as a consequence of contaminations in the soils. But they were able to go and target their responses in the areas that received biggest concentrations. And I kind of, as a scientist, I find it kind of remarkable that that they weren't using this kind of information before, but it also dawned on me how powerful this stuff was, because then the number of times we played this graphic over the weeks that followed was incredible. So we'd obviously struck home, I think. And this evidence-based information can be really, really powerful, much more powerful than words or kind of policy people trying to push agendas. The evidence-based stuff can really make a difference in some of these discussions. And another occasion where I saw that was when we were in the discussions about the climate debate. I'll show you a couple of pictures of things that have come from the climate models. I think why I felt it was so powerful was we were sort of beavering away trying to convince the politicians of why this was a real issue for them to think about. And a lot of the NGOs in this space were also similarly saying, you know, you need to worry about climate. This is really important for the environment. It's a big global challenge. And we weren't getting much traction, and we couldn't quite understand why. And then we realised that the answer was that we kept talking about models, and they really weren't thinking about models in the same way that we thought about models. So a number of people who've been working on building these climate models for 30 years, from really physical laws, bottom up, we weren't getting across the basis on which we tested and these models could be validated, compared to their understanding of a model, which we'd somehow made a load of approximations and guessed at some stuff, chucked this together, and that's what it was. And we kind of realised that that was the problem. So we did these two graphs, and again, we managed to hit home in a way that we probably had never achieved, I think, before. In any of the discussions we've had. And I think from that point, we saw an awful lot of traction in the previous discussions. But going back to the early point where I came into this, we took a number of learned societies with us, so it wasn't just a bunch of odd scientists that we took. We took a collection of learned societies from across the disciplines. Again, trusted bodies, so it was trusted information being communicated by trusted organisations, and that combination seemed to work well. So this is the data curve of temperature. And what we decided to do, it was, because we'd always been talking about projections out into the future, we thought, well, we'll run it backwards and show them how good we are, how good these models are at reproducing what we've actually observed. So, and we ran it with and without greenhouse gases in it. So this is human greenhouse gases, I would say. So this is the run without human emissions in it. Anthropogenic greenhouse gases. This sort of lighter curve is we run the models many times and created a sort of envelope of likely outcomes. So we thought this was our best model estimate, but this was a range of possible outcomes. And we were able to show that these models responded to natural events. So these are volcanic eruptions. And we were able to show that we could model the volcanic eruptions, and that but we couldn't represent what we'd seen in the observed temperatures. And when we showed them the run, but adding in the anthropogenic greenhouse gases, we produced that. And I think that was a sort of, again, really powerful imagery that people could connect in, that we knew. We didn't know the answer to everything. There's some areas that we're still a degree of uncertainty, that we don't know why the models don't represent it as close as they do. But in a general sense, we knew that the only way to represent what we could observe was by putting the human greenhouse gases in there, and that we kind of had all the processes that were going on, all the important processes, and so you could trust these things. So I think really powerful imagery, really powerful evidence delivered by trusted individuals, I think worked really well. But the science evidence in all this policy stuff is kind of never the only answer. I saw somebody present this once who was trying to push the issue of something called contraction and convergence, which was a way of getting countries to reduce their emissions. And they were shouting a lot about the US and China and how terrible they were, and they were responsible for it all. Again, they'd rather diplomatically hidden the UK in the EU emissions line, but UK's a fair proportion of the EU emissions line. And I thought, that's kind of odd, that doesn't really ring entirely true. So I went away and So this is overall percentage of global emissions, the top 10 emitters. And I did some work with a guy from Cambridge here, Dave Mackay, and he looked at per capita emissions, so per head of population. And it's kind of interesting that, well, of course, if you think about it, Canada have got less people burning an awful lot of fossil fuels because it's kind of cold in Canada. You need to heat the things. And again, similarly in Russia. And China actually doesn't look quite half as bad when you think about it in terms of head of population and the cultural impacts of how they use energy. So it was an interesting reflection for me that going back to this issue about frames of reference, it's never quite as simple as that. And the issue about public policy is that the science evidence is an important part of the process, but actually the social policy implications are even more important. And the only way you can make good public policy is by bringing together the science with the social policy aspects as well. And particularly in the climate area, I used to ask people about their frame of reference in a climate perspective. So perhaps I'll do that now. Put your hand, we were in a discussion about this earlier. If you think that you can solve this problem by economics, things like an emissions trading scheme, setting a price for carbon and letting the markets trade it. Yeah, okay. But how many people think we can technically innovate our way out of it? You know, we've got a history of doing this. Big challenge, we find a technical solution. Okay. So how many people quite like this contraction and convergence debate, which is one about, it's a sort of an NGO model. Everyone in the world has the equal right to emit the same amount of carbon. So we just add up how many people you've got in your country. That determines the limit that you should have, and everyone converges to their limits. Okay. It's a very utilitarian model, but it's an NGO kind of model. So how many people just think it's natural change and we can't do anything about it, so we should focus all our efforts, or can't do any mitigation, we should focus all our efforts on just doing adaptation. Forget trying to mitigate. That's the Nigel Lawson argument, I suppose, to kind of categorise in that way. Or then there's the slightly wacky geoengineering people. We put large mirrors in space and So, okay, again, there's a mix of people and probably there's a little bit of a number of those in solving the problem. And again, it comes from the fact that we all come at this from different frames of reference. So that's why I guess finding solutions to these problems becomes so complicated, is because you have to worry about people and countries coming at this from very different perspectives. The most interesting discussion I think we ever had around climate, which again surprised me, was when we drew this curve. A few of us went to see the minister at the time, and we sat down and they were thinking about forming the Climate Change Committee. And they were thinking about what this Climate Change Committee would do and what the Act would say, and should we put any targets in the committee. So we took this curve and we sort of said, well, okay, we're here now. If you want to set a target, government, that might be a 60% or an 80% reduction. So we said, we'll put our target down there. Okay, but how are we going to get to that target? Because you can't just do this and then suddenly go like that. So they suddenly cottoned on to the fact that it was all right setting a target, but if you set a target, you also have to define a pathway to that target. So we suddenly got a whole debate around pathways and how we might get there. And then we talked to them about, well, in these pathways, there are some levers you can pull. And if you think about the climate stuff, if you think about new nuclear, which has a sort of 20 to 30 year build program. If you think about renewables in any sizable context of renewables, well, that's probably 20 years away. Carbon capture and storage, feasible demonstrator projects, that's probably 10 years away. So practical operational models, again, are 20 years away. So if you want to start travelling down this pathway, all those kind of things which are all part of the solution probably sit up here. So if you want to start making some progress down here, all of the handles you've got to pull are around demand, around how people use energy. And they're the really, really difficult problems for the public and communities around energy use. But your levers are around demand. So I think starting from a really simple bit of science around the curve, we got into a whole really rich discussion about pathways, policy implications in demand and supply of energy. And it just shows how powerful some of this science evidence and science framework can be to hold policy discussions. But at the end of the day, actually the decisions that were made around these targets were vested in the social science aspects and the political aspects. You know, do we like fracking or don't we like fracking? Do we like nuclear power? Don't we like nuclear power? But at least it was informed by the evidence base. And I'll just finish, because I've talked a lot about stuff I did in big learned societies where you've got a lot of capacity. I have a policy team, so it's a bunch of people who specialise in policy work, who've got a background of working in policy. We're helping to drive this stuff, who all come from a science background. But there are different models and different bits of the ecosystem. And I'm involved with another organisation called Sense About Science. So that's very different, quite small, less than 10 people, very much focused on individuals who have wholly got an interest in policy change. And they've done a range of things. They have a sort of core programme about Ask for Evidence. So Sense About Science is really about getting scientific evidence out there in the public debate, particularly around communities who have kind of regular information shoved in their direction. Pregnant women is a classic example in the UK, who are sent all sorts of nonsense and rubbish about what they should be doing for their babies and then made to feel guilty about not doing that, without any evidence base for this stuff whatsoever. But we've also done some work on changing legislation with the new libel laws. We're doing some work at the moment on a campaign with Ben Goldacre on getting medical trials data published, because in the UK there's only an obligation, globally, there's only an obligation to publish successful medical trials, but there's no obligation for trials companies to publish negative trials. And if you're a member of the public, you probably think you're doing these trials for the good of medical research. Well, if it's not successful, that data never sees the light of day, which we don't think is right. So, big campaign around that. Now, those things are very different to what the learner societies can do, but you need both. This campaign for science and engineering is another similar example. There's lots of organisations like Sense About Science who have very particular focuses and can deliver more direct campaign-based work than probably the learner societies can do. But you need the learner societies to follow in behind and to embed the change and to give that change longevity. So the other interesting thing, I guess, around the policy programme in the UK in particular is this sort of interesting ecosystem of these small campaign-based organisations who can do the sort of more challenging stuff with government, underpinned by the bigger professional learner societies who can embed that change in policy and in frameworks and make sure that it's got longevity. So I think these organisations have very close working relationships, work quite closely together, which is something that's probably not seen on the surface. But there's quite an interesting ecosystem network around policy in the UK. So you tend to find that you have a science-based policy role. You'll find that you have a campaigns-based policy person. And then you find that you have a political policy person probably sitting with the MP or the minister or whichever bit of parliament is driving it. So you kind of have this three-way axis between the politics of the policy, the social change of the policy, and the evidence base of the policy. And I guess just to wrap up on this about what makes successful policy making, and people write whole books on this, so I'll try to synthesize this down into a couple of key points for me, is exactly that, is those things that fail, try to attack one of those elements. either just trying to shoving the science in front of people and saying it's all about the science, there's the evidence, just do something about it. Or they come at it from the social change, really campaigning issues without thinking about the evidence base so much. Or it's politically motivated. And I think the things that achieve real change have an element of all of them. They resonate with the government of the time. They're embedded in good social policy, but they've also got a strong evidence base. So I think unless you have all those three parts of that narrative, affecting real policy change is probably quite unlikely, or really a lasting policy change. So learner societies have an important part in this role. They offer good careers for people, I think, because they do such a diverse range of things. I think one of the interesting challenges, which we might be able to chat about in the discussion bit in a minute, is the fact that we have a lot of trouble in learner societies, attracting people to come into them and staying within them for enough of their career to be effective. But I think it does offer an interesting career and a chance to do these diverse things. And I think they are changing to a point where in 5 to 10 years' time, in this mix of broader information that we get across the internet and other ways of getting information, then these trusted sources are going to become more of an important place for government and for the public to go to. And so I think increasingly it'll be a more interesting place to work. That sounds like a place to stop and maybe take any questions.
Thank you very much for your talk, Paul. I'd just like to draw people's attention. Yeah, any questions?
How do we convince the US that climate change is real?
Yeah, well, interestingly, so I'm sort of out there on Saturday trying to do just that with the new those who are involved in the campaign. So I'm going out to talk to the American Physical Society, and we're meeting some of the campaign teams who are gathering around the new candidates. I find policy in the US quite interesting, actually. They are quite evidence-based, but it's kind of funny working in an environment where, on the one hand, they're very scientific, but on the other hand, a large proportion of the population still believe in creation rather than evolution. And, so it's a sort of rather interesting debate in the way that science is used in the US. And it's very different. And they're way behind Europe in terms of the way they engage the public in that debate. So almost entirely the public is bypassed, and it becomes a dialogue between the politicians and the science organisations. And I think that's a real mistake. I think in Europe where the public is far more engaged and active in that debate. And I guess in the US you find it's a debate of extremes, whereas we tend to operate more in the middle ground. But it's a global challenge, so we do need countries like the US, and similarly in the autumn I'm in China, so we do need the communities, both political and public, in these countries to engage with the problem. And I guess that means getting the evidence out there and trying to share it and dealing with it in the cultural context of their frame of reference. How do we achieve it with politicians? Well, I think the interesting thing about the US is they've begun to realise that there's quite a lot of economic value in engaging with the climate debate, as China has, because you end up being able to build nuclear power stations for countries or bring in some of the technologies like electric cars. We were talking earlier about new battery power. So they've understood that they can actually have significant economic gain from addressing these issues. And I think that's drawing them into the mix.
I was just wondering, when you were talking earlier, you asked us about what we thought was the best solution for sort of climate change. You said quite a lot about the different technological fixes, but there's also like attitudinal changes, like just changes in the way we consume and stuff. I was just wondering, in like a policy context, whether the government is like receptive to that at all, or whether it's mainly focused on technological solutions, and just like how you might deal with that.
So have you noticed any of it? Because government has embarked on a campaign over the last 10 years to try and bring about that social change. Have you spotted any of it? Which is a kind of interesting, because it's very low key, I think, in the UK. Have you? Yeah, anybody? Yeah, so there's a lot of interesting, sort of about the plastic bag stuff. We've had a lot of interesting problems in talking to the public around climate change, because they think the solution to climate change is recycling, which has really got, and this is a sort of a really difficult challenge, isn't it? Because recycling is a really, really good thing to do, but it actually doesn't help you very much in a climate context. So how do you tell the public, well, yes, you should keep doing that, but it's not actually any good for solving the problem that you think you're solving? So these things are quite complicated. So there's a number of campaigns that government have been running around use of transport, around use of energy, that the tariffs that have been in for moving to renewables, for example. These are all part of their kind of mix to try and have a go. But it's very low key, I think, much more low key than in a number of other countries. And I'm not convinced they've really stuck the message home, I think. But there is a sort of policy around, I think very consciously in the UK, they said the last thing we want to do is make people afraid of it or fear it, because people will resist any change. And the other thing we don't want people to do is make them feel powerless, because if you tell them there's a problem but actually not what they can do about it, then equally people won't engage with the problem. If they don't think there's anything you can do about it, then what's the point? So it's a bit about not making them afraid of it, and making them think that they're part of the solution. Shall we work that way around and then come to the front? Is that right?
Because you want to focus on education in schools about climate change, like maybe in primary.
In a number of these areas, I think, yeah. So big debate at the moment about the modification of human embryos, and I could list these GM crops. I could go on a whole range of things. And I think we don't bring in, I mean, there are good teachers who are doing this, so I don't want to talk ill about all kind of teachers, but I don't think we bring enough of what children see at home on the internet and in the news into the classroom that quickly. And I think contextualising what they're learning with modern day issues that they see in the news is really important, I think, in understanding the connection between things in the classroom and how that affects things in the world. So I think yes, but I think also we don't perhaps teach our kids enough about scientific method and approach. So we can't treat everyone and teach everyone to be a climate scientist. But if they're faced with issues and personal choices, we can teach them about where to look for evidence that's trusted and valued. And so if I'm going to look at this, am I going to believe this guy who's ranting on the telly, or am I going to believe this person who's telling me something that was in the peer-reviewed scientific literature? Because always the media are going to have an element of this wanting the two sides of the argument and sort of giving them equal balance, if you like, where there isn't equal balance of evidence. So how do we help our public understand where to look for the trusted information and understand the scientific method a bit, so you can kind of understand what people are, how they've arrived at the information and which is trusted. So I think we should do a bit more of that as well in our schools and with our adult populations as well in our outreach programs.
And are you able to go back to the table where you have the knowledge about scientific method versus how their faith, how big their faith was in result? So you said that surprised you.
Yeah.
And that's the pattern that I guess I'd expect, because I guess your surprise might be rooted in the classic kind of scientists, the poor nurses deficit model of if only the public knew more science, then they'd think that was the way to resolve their problems. But I would guess that a lot of the public who have no knowledge of scientific method find it far easier to be in awe of science and place it on a pedestal.
Yeah.
But actually, when you become more knowledgeable about science, you realise actually, for most of our environmental problems, it can't resolve them. And I guess I chatted to someone quite high up in the Environment Agency this week, who was wondering what they possibly do about the reputational damage that's caused by the flooding. And they say the solution is to educate the public in the science and the technology of flood protection, because if only they knew the science and how uncertain it was, their expectations that science and the Environment Agency could solve the problem would be diminished. So I think often, I would expect that to happen more often than not.
Yeah, you're quite right. And I mean, I don't know how many of you follow this stuff about public engagement, but years and years ago, there was this idea of a deficit model, which you talked about, which was kind of, I know the stuff, you don't, so I'm going to stand here and tell you the stuff, and then you'll know it, and it'll all be great. And then I think along came a guy called Arnold Wolfendale, who was the Astronomer Royal, and he was a Professor of Public Understanding at the Royal Institution. And he wrote a really transformational report, which was all about the way we should communicate with the public, which said, you know, the deficit model kind of has a place. Some people like to come to talks and listen to people, but actually that's not going to solve the challenges, just as you said. It's the problem that you mentioned in your earlier question. It's that the real challenge about public engagement is to let the public drive the agenda, and the scientists are there to be part of the discussion, but not controlling the discussion. So the dialogue should be public driven. And people still don't get that, I think. So they still come along to things like this and think because there's been a good Q&A that that's the public driving the discussion, but it really isn't. I mean, what Arnold really was trying to get at was that it's the public that set the questions, really set the questions, and I think that's where Sense About Science has real success, is that it's really public driven. So on the stuff about all trials, they formed a partnership with Mumsnet and sat down, because a big community group said to them, okay, what really, this is the issue, what do you think about it? What are the things you want to know about this? What do you want to ask the scientists? And you let the public drive the debate, and I think that's in our schools and in our kind of outreach programs, and I think that's far more successful, and all the evidence point to that being far more successful, yeah. Thanks.
I wanted to ask you, how much do you think that a kind of training in psychology is necessary for good communication? Because I'm not a psychologist, but it seems like we are quite often falling foul of things that must be fairly basic psychology.
Yeah.
Communication.
Well, it kind of seems obvious to say, doesn't it, that if you're doing things that involve kind of social interaction, you should have some psychologists, some social scientists, and people who've got some, if it's science communication. So it's obvious to say that we need people who know about all the elements of this working together. But you rarely see it, I have to say. You rarely see those communities actually collaborating to address these problems. And some of the more recent government campaigns have been trying to do this. They've been trying to get the best thinking about social science together with the scientists and humanities people to try and tackle this together. Kind of let's pool our knowledge about what works best and then help to deliver it that way. So absolutely, yes. And you see much more of that in the policy debate than when I first started. You saw, first off, you saw a lot of science advisors rocking up, like myself, and then it was very trendy to be a political advisor. And now you see the kind of social policy people in the mix as well, and often the combination of the people working together, which is, I can't think, much more effective, yeah, definitely. It's the worst thing ever to see a scientist trying to be an amateur social scientist, or vice versa. It just doesn't work, really. And why would you do it when you've got specialists in these areas and work together?
In terms of government policy, where do you think someone that's trained as a scientist can have the biggest impact? Is it someone like the IOP, or maybe the civil service, or maybe even party politics?
Yeah, so I'm quite a big fan of those who are advising government being practicing scientists. I sort of do less of it now because I don't think there's a bunch of other people who are much more up with the current thinking, who are working in it at the moment, who are much better placed. So I tend to find myself bringing these guys together than doing more of it myself. So I think what I would say in answer to your question is I think they should be practicing scientists for a start. I don't think it matters too much where that is, but probably depends on the discipline. Learner societies tend to pull knowledge from across the sector, so we can draw on scientists who are working in industry, scientists who are working in the public sector, and scientists who are working in universities. So we tend to pull teams of people together, and I think that's kind of more effective. But they could come from anywhere. Sometimes it's actually useful to get scientists from industry, because with certain bits of government they'll listen more to industrial partners. So sometimes university professors can rock up and say you should do this, but if Rolls-Royce turns up and says to government we should do this, then they're a big employer in the UK and government will listen to big employers. So it depends really. It's a little bit horses for courses, but I think they should be practicing scientists.
About the severe shortage of teachers and physicists becoming teachers, what is unique about this problem as opposed to the other subjects?
Yeah, it is actually a problem across all of STEM subjects, but it's particularly bad in physics. And I think I need to be slightly careful here about what physicists don't tend to be the most natural in front of public groups and like keeping charge of a classroom. So it's not a discipline that lends itself to the most gregarious characters you've ever met, which is one issue. The other is that we tend to actually see a lot of biologists in teaching science in schools, and one of the reasons is that and not to do biology as a career down, but actually there's too many people going down that route probably for the jobs that exist. So there's a big overcapacity in life sciences, so that many more of them come into teaching because there are less opportunities, not because there aren't interesting opportunities and important opportunities, just that the capacity coming through the system is so great, there's more than there are jobs for, so they tend to gravitate into teaching. Whereas the issue for physicists is the opposite. We have far too few physicists than we probably need in the workplace. So it's very easy for physicists to move into the workplace and bypass the teaching opportunity. And that's why so it's a problem in all sciences, but it tends to be a particular challenge in maths. Maths is a little bit the same as well. People can gravitate into a whole host of different career opportunities and often bypass teaching. So maths and physics in particular tend to struggle. It's a real challenge, and probably the best views of physics description, the half-life of a physics teacher, the point at which we get to is about 4 and a bit years, which is quite short. If you think about the investment in time in training a teacher, then to just have them in profession for about 4.5 years is quite... So the other issue is, once we got them in the profession, is keeping them in the profession is as good as the recruitment in the first place, I think.
So how would you sort of get rid of that feedback loop where you have like more people in life sciences teaching more people in life sciences, and then therefore making more people want to go into life sciences, whereas we actually want physicists?
It's a challenge, and I don't want to do down my biological science colleagues because there are great opportunities there, but I think one of the problems is they've been too effective at selling it to government. So government are ploughing a lot of investment into life sciences, but actually if you look at the statistics, the biggest growth in new innovation companies are actually in the engineering and physical sciences side, not the... So the whole of photonics as a community in the UK is bigger than the entire kind of pharma sector in the UK. Now that's not a statistic you would naturally recognise. So, but I think it's just there's a belief that this is a big growth sector in the UK, and actually I think the truth is that there are a number of growth sectors. So it's probably something about persuading government about these other areas of growth and development need some investment in, right back at the school level. But the other thing I'm kind of, some of my colleagues are very adamant about, we must have physics specialists teaching physics. I'm like kind of less feel the case. I think if you've got a good teacher who can teach science, we can train them to teach chemistry, to teach physics, to teach biology. So we should be investing a lot of effort in making them confident about teaching physics and bringing people through into A-level in physics and engineering. 70% of physics graduates go into a job in engineering. So if we're serious about delivering the high-value manufacturing program that we're trying to grow across Europe, we need an engineering community, which means we need a physics community, which means we've got to get some of these science teachers being comfortable with teaching physics.
So, like, hypothetically, if you became aware of an issue that's something like the next climate change, so something with like increasing amounts of evidence that this is a kind of global problem and that it requires basically unpopular policy actions, like what levers are kind of available to you personally, like how much impact could you kind of personally get people to do something about that, and what kind of careers, what kind of people are best placed to be able to get some action moving on that?
Yeah, I mean, I don't necessarily think it's that different to areas when the public policy is popular. I rarely think public intervention by government in public policy is rarely popular in any case, but I think often the skills and the people are the same. I think various governments do less or more intervention in the policy arena. The current government likes to be very light on policy. The previous government before the coalition liked to be very heavy on policy intervention and driving things through that route. Quite often policy is challenging when you intervene in things. But I think the nice thing about science is it's sort of value independent. The evidence is the evidence. The social bit might be the more challenging bit. So particularly as a scientist, your job is there to share the evidence. It's then up to the politician and the social policies people to put that in a social context and decide whether it's politically acceptable or not. But I think that decision shouldn't come into the scientific evidence. You should share the evidence, good or bad, and then we elect our politicians to take decisions on whether that becomes policy or not. The other mistake is to think just because the evidence is there, then we should do something about it. That's the job of our politicians. That's why we elect them.
Well, I'm a bit concerned about how you portray the whole interaction with politicians. It looks like they are only interested in flashy graphs and getting things that they actually understand. And how, I don't know, if you think that they might be too scientifically illiterate or something like that, because it looks like if you went and spoke with a politician and gave him something which was just a lie, you had just invented a little data, just handed in nice simulation that he liked, would you be able to convince him?
It's a good question, and a lot of my colleagues get quite exercised about the fact we don't have enough scientists in Parliament. I'm less worried about that. The more I work with politicians, the more I'm impressed by how good they are at absorbing information very quickly and contextualizing it and understanding the issues that you're trying to get across. By nature of the job that they do, they have to be specialists for a short period of time in lots of things. So they're very good at absorbing information, taking things on board, processing it, getting to the problem and the challenge very quickly. And you know, the more I work with them, the more I'm impressed. And I genuinely rarely meet a politician who is not genuinely interested in doing the right thing and making a real difference. I mean, I know the media kind of likes to play them in a different perspective, but that's not my experience of most politicians are really trying to do the right thing and to try and get their head round, work at getting their head around the information. So I often, it's the sense of my job to help them get to the point where they want to be and not to try and drive them down a particular avenue that I want them to go, but to be there to in a genuine advisory role to help and guide them through that process. And I think the best relationships work like that. And of course, it's not always graphs and charts, but sometimes when you have to absorb a lot of information that you don't have that background in, you have to think quite a lot as a scientist about how you're going to deliver that to them.
That's great. Yes. But if someone didn't want them to, if someone wasn't in your position of being just an advisor and trying to get them through the good, just trying to think about the data and deciding by themselves, or just went in with the data and just wanted them to
do what they wanted them to do, would they be able to recognize the good thing to do by themselves, or do you think?
I think it's often a challenge for us to get complex information across, and I think unless you find a way of simplifying it and getting the key messages across, then they're not going to cut through it very easily. So you're probably not going to get much if you turn up with a huge report or a huge set of data, which is why the international panel, Intergovernmental Panel on Climate Change, do a short synthesis document for the policymakers. Is when we started writing these things, we found that the fuller documents were a great way of synthesizing the evidence, but we needed something simpler that got the key messages across, and if we're going to get people to take it on board. And I think that's true in lots of things lots of policy areas. There's a question over there.
Well, no, it was just more of a, so you said that evidence is, we should just look at the evidence and, free of values and that kind of thing. And here you were talking about how you would communicate, how would you communicate evidence to policymakers so that they would understand it. But surely isn't it quite problematic to sort of treat science as a kind of value-free kind of thing? Because surely, like, all science is quite heavily embedded with a lot of social values. So.
Really, yeah. No, I agree. It's really, really difficult. In fact, probably if pushed, I would argue that there isn't any science that's free from values, because human beings are doing it and we have our own value system. And I used to find myself in really challenging situations sometimes and having to check myself and saying, okay, well, this is what the evidence is and this is my opinion of what the evidence is telling us. And that, of course, comes with a range of values in it. And to trying to be honest about what I think comes straight forward from kind of the models or the data, and then what my interpretation of that is, and where I think I'm adding my values into the process. But you're quite right, it's an extremely difficult thing to do, and to remain wholly independent, because you've looked at the data and evidence yourself and you've already decided what you think the right outcomes should be from this, probably. And to try and detach from that is really, really difficult. And the really best science advisors I've seen are able to do that really well and dispassionately. But I think you're quite right, none of it's entirely value-free. And that is a challenge.
Is there evidence that a sort of alternative group of subjects which are drawing people away from physics, who would otherwise have carried on with physics? Because
yeah, one of the things I see quite a lot is just on women going into medicine, girls studying A-levels, is that there is a drive, particularly for people who kind of want to go through the sciences, to go into medicine. But if you kind of do the equations, you realise that it's a bit like the life sciences. Medical schools are full. The chances of getting into medical school, even with good A-levels, or if you want to do the degree conversion, is quite small these days because the capacity is not there. But if those people had done physics at A-level, rather than often they would choose a subject that, whether it is or isn't, is not in my judgment, but is perceived to be easier, like psychology, for example. So they would do a biology, chemistry, and then something that's supposedly a little bit lighter and easier. I don't think they are, by the way, but it's a perception thing. And then get there, find they can't get into medical school, but if they'd only done physics, they could have done medical physics. Most treatment and most diagnostic systems are physics-based these days in medicine. So there's a whole host of things that could open up. They could go into the kind of interesting work in development in cancer treatment. If you look at the Crick Centre, biologists, physicists, chemists working together. So you see frequently choices made at A-level that have really narrowed down opportunities of people, and it regularly frustrates me that our careers advice is quite poor and really not focused on keeping breadth of choice at the right stage in the process. I feel really disappointed when I see people who really have got a kind of wanted to do some stuff but only realised later, if they'd have only chosen a different combination, there'd have been a whole range of opportunities open up to them. I guess the one thing is, in these days, it's relatively easy to go back and post-correct that. It's maybe expensive and takes a bit of time, but you can kind of change your direction a bit later in life. But it's kind of frustrating to see that if only we've had teachers who've actually been in industry and come back into teaching and therefore can give context to people making those choices, it will be much better.
You mentioned previously about the value of having a corporation give advice to the government as opposed to scientists on their own. Perhaps specifically to climate change, but the biggest STEM sector in most countries would be in the energy sector. So in the UK it would be probably BP, and they have their own agenda with the climate change debate, and they themselves being a very large employer as well. Their advice to the government would, in many cases, be counter to what the others would want. And there are exposed cases of them funding scientists to disprove global anthropogenic global warming, etc.
Yeah, it's a funny sort of mixed reaction, I think. So sort of yes and no. Interestingly, I mean, they're businesses and they want to be building the things that government are funding. So a lot of these energy people, they want to be building the renewable technologies. They want to be building the nuclear power stations, you know, EDF. They want to be building the kind of interesting battery stuff that's going in new cars. So they do want to follow where the trends are going, but they want to also benefit and sweat the asset from the investment they've already made in things like oil and gas. So they have the kind of split personalities often. You see them pushing both, actually. So it's a little bit more complicated than people who are having direct vested interests. Yes, of course, we've seen fossil fuel lobbies funding research, but I think that's actually getting less as they've seen the opportunities from moving into these new technologies as that started to emerge, because there's new business growth in there. And that's going back to the point earlier about businesses sending signals. One way to do that is for government procurement and government business to focus less on that and more on these new areas, and that industries will follow that trend. Actually, the biggest sector for STEM in the UK happens not to be the oil and gas, but it's in the high value manufacturing sector that's growing in the UK, in aerospace, in photonics, in quantum technologies, and that's gaining a much bigger voice in terms of the STEM sector. And interestingly, driving this apprentices and technicians route, these days it's much easier to move between apprentice technicians and sort of higher education academic qualifications and go between the two. It's not as simple as it was perhaps 20, 30 years ago where you took a higher education route through university, or you took a technical route through a college. These days you can move between the two, and employers expect you to move a little bit between the two. And those sectors are driving that debate with government, and you've seen that in the apprenticeship levies discussions that have been playing out over recent months. And you'll see more of that going forward, I think. And learner societies are increasingly getting involved in the further education agenda with colleges, which is perhaps a space they've had less involvement with over the years, which I think is quite an exciting opportunity.
I had a discussion recently with a friend of mine that in the Second World War it was clear that as a scientist you work on something that helps the war, build nuclear bombs, for example, and in the Manhattan Project there was smart scientists working there, and we found that today it's not that the biggest problem there is at the moment is climate change, and there isn't the same sort of thinking. If you're a really good scientist, you should work on stopping climate change. And do you have any ideas how we can create such a drive to get the smarter scientists to work on that problem?
Yeah, I mean, I think you're right. There's probably nothing like a war to focus your effort and energies. But we have seen, not quite parallels, but we've seen examples where focus has created thought and investment and direction. So, you know, the Apollo program, which is probably the thing that got me into science, watching the moon landings. But that kind of targeted thing about, okay, we're going to send someone to the moon. We've seen it with there was a big UK-US program on tackling cancer. So there's been a very high profile push to let's beat cancer within 10 years. was the push, and a lot of effort has gone into that. So you've seen big centres like the Crick being built, and scientists, good scientists coming into those areas to join those challenges. We have put a huge amount of investment into climate science. When I was doing it 30 years ago, when I first started playing around with models, there was no investment. Now, you couldn't get a research grant for working on a climate model. Nobody was interested in the end of the 70s, early 80s. Just nobody was interested. There's no funding in it. But now, I think in some parts of the research councils, you can't get a grant funded unless it's got climate in the title. So I think you can change direction and shape and focus. The interesting discussion for me is how much do you let the science community drive that, and how much should be driven by government? So a big debate in the community about something called the Haldane Principle. I don't know if you've come across the Haldane Principle, but the Haldane Principle is broadly that we should invest in excellence in science, and scientists should decide what's excellent by the process of peer review. You put in your ideas, your colleagues and community say that's good or bad, fund it or don't fund it. And that's worked quite well for the UK. We probably get the biggest impact in science for what is a relatively small contribution in terms of investment in our science programme globally. But we've probably got the biggest impact because of the process that we operate grant funding and the way we fund our science and the way we operate the peer review process. But increasingly, governments want to intervene in that process and say, I want one of those centres here, and I'm going to put the money there because I've got a political problem in the northeast, so I want to create employment. So maybe this centre should go here, but actually I'm going to put it there because it's going to make some jobs. That might create jobs, but scientifically it might be suboptimal. And that's where the kind of interesting discussion comes about what's the role of the political process versus kind of the science process. So interesting about how we choose what we invest in and how we create these priorities. Should that be politicians or should that be the science community who are driving innovation bottom up? And probably you're always going to have a little bit of both.
Right, maybe we should wrap up that. I hope everyone enjoyed the talk, and thanks once again, Paul.
Well, thank you for staying.